Here are our PDF for various distributions. Remember that for uniform distribution we can integrate PDF to get CDF, and then using the inverse transformation theorem to get samples from uniform distributions, and the samples which we are getting are basically serve as an input for our simulation. Second one is exponential distribution. We can integrate that PDF also. And for normal distribution, because it's not in the closed form, we cannot integrate it, and we have to use a built-in Excel function to get samples from normal distribution. So whenever the PDF is given for a distribution, what I need to do, I need to integrate it from minus infinity to x. Minus infinity will be the lower bound or the lower limit of the PDF. So in order to calculate the CDF, which is also represented by capital F of x, so when I'm integrating this 1 divided by b minus a, remember that b is the upper limit support and a is the lower limit support of a uniform distribution. Because it's a constant, I can always take it out of this integration portion. After integration, I can get f of x is equal to x minus a, b minus a. F of x here is the CDF and it is the RAN function. Small x is basically the values which I am getting from the uniform distribution. What does that mean? X is a random variable which is following a uniform distribution. So here note that f of x is the random number generated by the RAN function in Excel. Small x is the value for a given value of f of x. So I'm interested in calculating the value of this small x. What does that mean? That let's say I have a lower bound here, a, and upper bound, and f of x can be a random number in Excel using this RAN function, and this value will be between 0 and 1. And because I can generate infinite numbers between 0 and 1, so I can generate infinite values of x also. This is the inverse CDF graph here, and x are basically my samples here. Rand function which is also equal to f of x. So Excel can choose any number between 0 to 1, and going in this direction, once it touches this CDF curve, if I go down in this direction, it will give me the value of x. Let's say I'm choosing 0.3, or let's say Excel is choosing, so here and then coming down, so I think it's around maybe 180, something like this. Let's say in the next iteration this value rand function is giving me a Excel is giving me a value of 0.9, right? So what's gonna happen, this will touch it here, and then when I come down, maybe it's around 240, something like this. Okay, so from this I can see, okay, the upper bound is almost 280 and the lower bound is almost maybe 140. Means that when I'm generating numbers following that particular distribution, so it the numbers I will be getting will be within my lower bound and upper bound. So this is the same thing which I just explained. let's say we are let's say we are taking this um, random number as point 0.1, right? So I think it's around maybe 160 or something like this. Excel can calculate it very easily for me, and we will solve this with the help of Excel sheets. So when I'm sampling from a probability distribution, what I need to do, first I need to generate random numbers, and random numbers, for that I will be using uh, rand function in Excel. Second step would be to link that f of x with small x with the help of inverse transformation theorem. Third one would be to like repeat step 1 and 2 for the desired number of iterations. So in Excel, we can do like, we will solve a very simple problem for maybe 100 iterations or 1000, that doesn't matter. And next step would be to collect all the small x values and calculate the desired statistical matrix. So like, I'm interested in mean values, standard deviation, percentiles, conditional expectation, um, whether I want to calculate variance. In addition to that, the values which I got in step 3 also serve as an input to my simulation model. Second one would be exponential distribution, and exponential distribution is widely used to model random arrivals in continuous time, especially when the inter-arrival time are independent and identically distributed. So such as customer inter-arrival time, times to failure, and we have one parameter here which is lambda. We need to know that mu, which is the mean value, is equal to 1 divided by lambda. So what does that mean? If lambda, which is arrival rate, is 0.2, emergency calls are arriving in 1 hour, this means that 1 divided by 0.2 is 5, means the average response time of an ambulance is equal to 5 hours. Uh, Here you can see PDF is given, and I would like to integrate it from minus infinity to x in order to get f of x. Because exponential is a non-negative distribution and the lower limit is 0, so I'm replacing minus infinity with 0 here, and after integrating I get f of x is equal to 1 minus e power lambda x, but I'm interested in finding the value of x here. So what I need to do after applying natural log on both sides, I get the value of x. X is the sample and f of x is the rand function in Excel, and lambda rate is arrival rate, which is also 1 divided by mu, and ln is natural log. Here I have various lambdas. So for lambda 1, lambda is equal to 1, lambda is equal to 5, and lambda is equal to 2. So here I have various density curves for exponential distribution.